Hello and welcome. In this video, I would like to explain and demonstrate how to get the most out of your existing PC. Everyone is always looking for the best upgrade path to gain the most performance at the lowest possible cost. The best way to evaluate this would be to list out your current PC specs, CPU, motherboard, RAM, graphics card, etc. From there, work out what is the part that is potentially holding your system back. In most cases, there are upgrades that can be applied to boost the performance of your system. In my particular case, I'm looking at a 3-year-old Intel i5 6600 CPU running on a Gigabyte H170 D3H motherboard with a single 8GB stick of RAM. This motherboard is compatible with DDR4 memory, so the plan is to install faster memory in order to future-proof a potential AMD Ryzen motherboard and CPU upgrade further down the line. The parts purchased for this upgrade are 16 gigs of dual-channel memory. For this, I've selected the 3600 MHz CL16 Ballistic Gaming Memory Kit with RGB. We're also going to upgrade the 120 gig SATA SSD with a 500 GB Western Digital Black SN750 NVMe drive. Okay, let's jump right into it. Right, let's get started by opening up the case, removing the cables, starting with the graphics card, SSD, taking out the front panel, and giving it a bit of a dust, since there's about 2 years worth of dust build up there. And completely remove the cables, the SATA cable from the motherboard. Next, let's remove the hard drives. Undo the 2 screws on the inner side of the case and the 2 screws from the outer side. Next, let's start removing the internal cage that holds the hard drives in place. This is to clean up the case as it needs a full service. Unplug the power and SATA cables from the hard drive. Continue to remove the cage. Next, let's remove the power supply. There's a lot of dust build up there, needs to be wiped down clean. And let's also remove the graphics card. There was a safety catch inside there. I didn't catch it on video, but needs to be released before pulling out the graphics card. Next, let's remove all of the motherboard wiring, the front panel connectors, the front panel USB, continue to remove all of the wires connecting to the motherboard. And let's start to unscrew the motherboard from the chassis. Disconnect the fan and remove the final 2 screws at the top. And there we go. The motherboard should just simply slide out. Let's continue to open up the rest of the case so that we can give it a very good clean out. With the motherboard all cleaned up, we can start mounting the new parts, starting with the NVMe M2 SSD. This is a 500 gigabyte. Unscrew the securing nut and simply slot in firmly and push down. It's normal that the drive will lift up, so you do actually have to apply a little pressure to hold it in place while screwing in the holding screw. That's it mounted. Next, let's look at mounting the new memory that's been purchased, which is 16 gigabytes of DDR4, 3600 megahertz speed. When mounting, make sure that the notch lines up correctly. It should just drop into the slot and then firmly press on both sides until you hear a click. Like so. Mount the second stick. Again, double checking that the notch lines up correctly. Slide in and firmly press down until you hear the click. There you have it. Memory and storage have been upgraded. Now we bring back the clean case. It was completely dismantled with all of the wiring disconnected from the chassis, therefore allowed us to clean it with water, as there was quite a lot of dust buildup over the last 2 years.
The top half of the cabling is for the USB front mounts. Run those tidy so that they can be completely cable managed. Next we run the front panel power button connectors through the chassis and secure the front panel to the case. Let's just fold the wires facing outwards so that we can start mounting the internal components, starting with the hard drive cage. Next is the bottom half of the hard drive cage. Next we reattach the motherboard backplate. And then bring the motherboard in and seat it on the stands, carefully aligning, making sure that all the 6 holes line up. And screw it down. Now we can start reconnecting all of the front panel connectors to the motherboard, running the cables through to the back before feeding them back through to the front to be connected. This greatly helps with cable management. Same thing for the USB and audio connectors, run them through the back as well. now for the USB 2 and audio connectors. Again, passing via the back and through the hole closest to the point of connection to the motherboard. USB 2. And that's the front side done. Now to tidy up the back of the case and do some cable management. Straighten out the cables so that when they are tied, they do look tidy. Make use of the side of the case to hide as much of the wiring as possible. Use wire or cable ties to hold the cables in place. As mentioned earlier, use the side of the case to tuck away the cables. Next, let's bring back the power supply and remount it. Mount the power supply with the 4 screws on the back, making sure it's secure. Next, let's connect the 24-pin power supply connector to the motherboard, running it through the back first and then back to the front near where it mounts to the motherboard. Also run the power cable the CPU power cable up to the top. Modular power supplies typically are better at handling cable management, so that you don't have to tuck away so much mess. So to run the CPU power cable, run behind the case as much as you can before pulling through to the front. For the 24 pin, there is a slot that drops it right next to the connector, as seen there. And you can just fold it back and plug in. CPU power. Plugs in at the top. Next, we bring back the graphics card and plug it in. There is a catch on the front which should clip into place once secured. And there you have it. Everything's connected and fully functional, and the build is complete.
As you can see, in this upgrade, there is a lot of potential performance to be realized with the right upgrades being applied. Depending on your current system, you can do what we did here and plan upgrades that are compatible for a future build. Take note that the RAM used in this build is capable of running at 3600 MHz. Although the current motherboard can only run at 2133 MHz, the memory is compatible and does step down to match the maximum speed the motherboard is able to support. When the time comes, the motherboard and CPU will be upgraded, and both the memory and NVMe storage can be brought forward to the next build. Thanks for watching, and if you like the content, do remember to like and subscribe. If there's anything else in this video that you are not clear about, let me know and I will respond in the comments below. Thank you.